Hey guys, my name is Tyler Wilson and I am one of the Physics 2 LAs for this spring semester. Now, in this laboratory, which I'm pretty sure is Laboratory 2V, you should be talking about resistance circuits. And so you'll learn about three primary types. One of them will be a simple single circuit with just a single resistor. You should learn about a parallel circuit with two resistors. And you'll learn about another type of series circuit with two resistors as well. And you'll learn more about what those are and what they do as you go through the lecture and as you go through the laboratories for this course. What I'm actually here for as an LA is to talk about the more experimental component, because if you've never used these devices, it can actually be kind of confusing to make sure that this works like as intended. And so that's what we're going to be talking about today. Now, one of the most important components to constructing a circuit, at least in this small applied context, is using a device known as a breadboard. Now, the breadboard itself doesn't actually do anything special in particular, but it's pretty much the backbone of building a circuit. And so we're going to have to talk about it at least a little bit. So what you're seeing right here is there's actually copper strips inside this plastic case, and these holes are what you use to actually connect the circuit together. Now, here's how it works. Hopefully you guys can get a good zoom in on here. If you look at the holes on the row, they're actually all connected to each other. As in, if I plug a wire into this node, and you gotta actually shimmy that wire in a little bit, and then plug a wire into this node, that's not gonna do anything helpful for you. Whereas the nodes that go down vertically or are separated by this gap are actually not connected at all. And so they do not interact unless you make them interact. So the line of holes right here, if I connect one end of the terminal into here, and then connect another end, now these two nodes, which would have never interacted previously, are now connected inside this circuit. So that's how that works. Don't be afraid to kind of firmly grasp it and make sure that you shimmy it out as you pull the stuff out. Now, one of the really important components to this circuit is actually going to be your switch. And what this does is actually controls which components on a circuit are connected to each other. So, for example, I can have three wires that are lined up that currently are not connected. And if I have the switch to the right, that means this orange wire and this white wire are connected to each other. If I turn the switch into the other direction, that means the orange wire and the black wire are now connected to each other, but neither of them are connected to the white wire and vice versa. Right? And we can actually verify this with what's called a continuity check, as I'll describe in a moment. So the next thing that we're pulling out is the multimeter, which I'm pretty sure you guys have used for Lab 1, so hopefully you're a little bit familiar with it, and we're actually going to turn it all the way into the yellow little flash symbol that's down here. And what this does, it basically tells us if a circuit is connected or not. An easy test to know that you have it on the right button is if it makes a weird noise when you connect the ground and the hot together. You hear that? That's how you know that the circuit is connected. If you want to check to make sure that you're using the switch correctly, you can actually do this continuity check on something like the orange and white wire like I currently have. So I have the switch in the direction to where the orange and the white wire should be connected to each other. And if I place my fingers, and kind of hold these two ends together, we should actually hear the noise for the continuity device to know that the circuit is connected. And indeed, we are actually hearing that noise. If I turn the switch in the other direction and then try and still hold it, nothing happens, you see. It's not connected anymore. Now, another very important component to any circuit is actually going to be what's called a resistor. That's what this device is right here. Now, an important thing to note, you should never, ever, ever turn on a circuit unless there is at least one resistor connected to that circuit. And the reason why is because the resistor slows the current down and lowers the value enough to where it doesn't burn the circuit up immediately upon turning it on. And if you want to connect a resistor to the circuit, you would just like any other normal wire. Make sure you, kind of shimmy it into the breadboard as you do. So kind of give it some oomph. Don't be afraid to kind of wiggle it in there. And then you can connect your resistor to another node like so. And so now those two, this line of holes and then these lines of holes are now connected as if there was a wire connecting them, except now it's a resistor instead. Now, certainly last but not least, when talking about circuits and electronics, is the multimeter, the king of measurements in the world of electronics and electromagnetism, right? So this is the bad boy that allows you to, that's going to help you learn about circuits a little bit more. Now, if we want to record something like the voltage of a circuit, and in particular record the DC voltage, then we're going to want to turn the dial to the left-hand side where there shows like straight lines next to the V, because that means we're recording DC instead of AC, which would be a squiggly line, right? So in this case, you're going to be using a 9-volt battery, so you're going to want to turn the dial somewhere to the either 2 or 20 sensitivity range, because that's going to be the voltages that we're most likely to measure. If you want to, say, record something like the current, then you're going to want to put the dial to the kind of left hand, or not the left hand, the right hand side of the multimeter so that you can get current measurements. And once again, depending on the context, you'll either want to set to 200, 20, or even at 2M to measure the current of the circuit. Okay, you should have learned everything that you needed to know in order to do this laboratory, and if you have any questions, you're feel free to contact Mr. Indergaard, any of the LAs, and would be happy to help you if you come during office hours, and enjoy the lab as best you can. See ya.